Hello, everyone. Welcome to Developer Week 2022. It is my pleasure to introduce to you our next speaker of the day. His name is Tashish Jawali. He is the CTO and co-founder at Symbol AI. Please join me in welcoming him to the screen. Hello there.
Hey everyone. Hi, thanks Chelsea for the introduction. Hello everyone and good morning for whoever is in the same time zone as me. And Today we are going to talk about how can you enable conversation intelligence with as easy as hitting just few API endpoints. And believe me, it's not that easy today, at least. And we are gonna take a walk through this journey and see why that is, how that happens, and what are some of the examples that we can do it through. Little bit about me. I'm Toshish. I'm CTO and co-founder of Simple.ai. We build AI that understands human conversations. Um, First things first, why isn't it already easy to build conversation intelligence by just hitting just few endpoints, right? Like we need to start there. So there are a lot of jargons that you might have heard in various different contexts, and pretty much these four sums them up um around the similar context, right? However, this is very tricky, and it's important to understand what they really mean when you're reading about them in industry literature or even in research literature. So, conversational intelligence in general means overall intelligence of having conversations, whereas conversational AI specifically points to an AI system that is capable of responding or holding conversation with humans. So, typical examples of this kind of intelligences or AI systems are Alexa or Siri, that you probably are familiar, and most of the chatbot applications. Conversation AI refers to an AI that can understand conversation and potentially can also perform that conversation with a person, hopefully. And the conversation intelligence in general is the study of how to build and what those entire ecosystem that involves conversation AI, which is a study of AI systems that can understand human conversations. Now, when we talk about conversations, now in this context specifically, we obviously know human to human conversations. We talk all the time, and human to machine conversations are pretty well understood as well now due to Alexa, Siri, Google Assistant like systems. So these are not new. These are just here to put us into perspective what it's easy and what is not easy. Human to machine conversation has become easy over a period of time, and we are going to take a look at why that is, what are the nuances, and how to think about it. Um, However, when we talk about human to human conversations, these conversations, like you do on day-to-day basis, are pretty complex. And if you compare your conversation with Alexa versus your colleague or a customer, if you have ever been in a sales call or customer call, those are extremely complex, right? So obviously understanding them is not as simple or as straightforward as human to machine conversation. And that is one of the reason why it is not as easy as doing it with single API call or things like that yet. And we are going to take a look at what is possible and how to actually get to the point where you could do that. Now, very important thing to understand, conversations are not documents. Conversations are um, uh, free flowing articulation of a thinking process, which is not formally written, well articulated, or even accurate in its whole. Documents are like that. Documents are the result of well articulated and formally defined content, which is why Most of the techniques, NLP techniques, have been built to process documents, and they typically don't work on conversations. When I say don't work, meaning technically you could make API calls, but you would not get results that would be meaningful in any way, because they are not simply built for solving the problems that are actually calibrated towards human conversations, naturally flowing human conversations. So, just to get into perspective of what human conversations may or may not comprise. So these are some of the uh, very high value human conversations that happen in day-to-day life of any working professional. Apart from this, there are a lot of other uh, other conversations that we do all the time in our family time and with friends and just catching up with buddies. However, we are going to use some of the high value conversations like this as an examples to put us in perspective, and it's also easy to relate the impact of getting value out of sales calls versus getting value out of a friendly chat with your buddy. So key thing to note, even though these conversations are typically targeted towards a specific goal and agenda, they still are very chaotic, and they still don't follow a fixed flow, a rigid fixed flow like a chatbot or a virtual assistant would. And they are very contextual in nature. So you have to understand the context before you can actually understand sales call, especially if you are a AI machine, right? So two different modes in which you could think of getting value out of such human conversations. One is obviously real time. As conversation happen, AI sits with you in the call or meeting, and they actually perform different things for you, or at least note them down and let you know what is happening, what is not happening in real time. A typical example of this is, imagine you are on a sales call with customer. Customer asks a specific thing about your product, and you might take some time to find it, and it might reduce your probability to close the deal because the experience to now customer is not good. But imagine if there was an AI that actually understood that, hey, customer actually wants to understand more about it. The best way to do that is share this specific document and give that option to you, and you could just click a button and you could share that. So by just doing that, you actually did something called as suggesting, you actually performed in-app action in a standard development app-centric world. But the action was suggested contextually by understanding what the sales call is actually about and where are we in that sales call and what is the right thing to do. So things like that can be done in real time. Other examples, few examples of such things are, obviously you could monitor just what's happening. If somebody is being rude on customer care call, a system can detect that and tell them, hey, please be more empathetic. Those kind of things. It can even do more, do the actual actions for you instead of suggesting them, if they are, probably if you would not want to do very important actions like that though. And then the other mode is when the conversation has already been done, and after that conversation, now the AI has gotten access to your conversation either through audio or video recordings in any different way, but typically audio video recordings. And then now it's trying to understand what happened in that recording and then try to make sense out of it. It could be just noting down something like minutes of meeting, or it could be more actionable, such as figuring out the follow-ups that need to be done from that call. All these things, by the way, can also be done in real time. It's just the mode in which you would like to do that, and it may depend on the specific circumstances of your app, right? If you have access to real-time raw audio or video stream, you might be able to do something in real time. If you don't, you probably would prefer doing it in asynchronous mode. That could be another deciding factor that you might want to consider in this case. But in general, there are these two different modes in which you would uh, think the problem space of understanding human conversations. Now, A typical human conversation is always temporal. It always moves in the time direction, which means you need an AI system that can actually understand the temporal aspect of conversations, and it needs to stitch them together. They they always surround around few specific concepts, such as it could be a specific product, a specific pain point problem, it could be an interview call, it could be technologies or whatever subject matter expert is. But essentially, conversations are shaped by specific concepts in a temporal dimension, and they have causality between those concepts. So one thing leads to other or affect others, right? So if a customer on a sales call is telling you that, hey, I have this problem in my workflow, or this is my day-to-day issue, right? I would like a solution for that. That is your causal response as a salesperson to give them the right recommendation and the right solution, and then potentially achieve something to do that. But all of that is a chain of events that are causal, and sometimes these causality can even extend outside of that specific conversation. It might be a follow-up call from the last sales call. It could be a follow-up brainstorming meeting based on your product review meeting you did last week. So the causality is a key and central part of human conversations. They are very natural, which means there is no rigidity to it. You really don't know how it's going to go. You have to, as a AI, from the AI's perspective, you have to model the natural flow of these causality between the concepts that are being discussed in conversation by one, two, or more parties in a temporal dimension. And by nature, because it's natural, it is not perfect. It's not formal. It's not well articulated. It's really a raw sequence of thoughts that people are uh, just uttering based on the actual situation in the conversation. And it is contextual. Like I said, all of this needs to fit into some kind of problem space. That is the whole context of how this conceptual causality and natural flow of events is going to happen in the conversation. And they always relate to something that is outside of conversation. So you're going to refer to a product or a city, or it could be even something abstract like product management and things like that. So but the key thing is humans are always going to relate something outside of the actual scope of conversation. So it needs to have the relational aspect, and you loosely know what those relations are going to be, but many of the times you don't even know what a customer is gonna say exactly what kind of thing. So it needs to have enough ability to contextually relate to entities and temporally define them, conceptually model them, figure out the causality of the events, and model the naturality of the conversation. Well, having said this, these are one of the few of the key properties of what conversations are from the AI's perspective. And this is why it's quite hard that there is no system that can just do that with few API calls, and it ends up being really, really complex system, right? A typical machine learning system, even if we ignore what is going on in that model box, which is already complex, if you're going to solve problems like that, it involves other additional overhead to it, right? It has typically you need a very robust and huge amount of training data, which in itself is very expensive and time consuming activity. And you need to then use very resource intensive resources, GPUs and even TPUs sometimes, to train those models after you figure out how to build one. And then you need to do the similar things with multiple iterations, multiple cycles of testing, benchmarking, deploying, and so on. And maybe after that, at one point, you will have an model that can do inferences in your application. And we are not even talking about engineering challenges like latency. If you're going to do it in real time, it needs to be probably less than 300 milliseconds of latency with such a complex and huge model. So there are other challenges involved there too. But ideally, wouldn't it be great if it would be just this and there is no need to do that training and testing and benchmarking cycle? And even this model is kind of pre-built and you probably don't have to go through all of that pain to build something interesting and useful based on a model. So the real question is, what does it take to do that, right? So this was back in 2015, Google published this paper. It's a very popular paper that talks about the hidden debt, hidden technical debt in in um, in machine learning systems. So if you see this little black box here is actually your model. That's the machine learning model that you have, and all these big boxes surrounding it is the surrounding ecosystem and built of processes, infrastructure, development practices, and all of that, and observability and stuff like that to make a production scale machine learning system possible. And in this is the added technical debt, which usually is not understood well, even when the models themselves are so complex. Now, all of this adds to this why question about why it is kind of hard to do that. Now, generalization is a key to solving and making this simpler and scalable. So I'm just going to use this one example to explain what generalization is. So here, imagine there is a model that exists. It's built to detect animals. It's an animal recognition model. Given a picture of animal, it's supposed to predict what animal it is, right? Now let's say that this model has never seen a picture of zebra, but it has seen the description of zebra, and it has seen the description of horse, and it has seen the picture of horse. So what this model in this case would be able to do is actually relate the description of zebra to the description of horse, figure out the nuances between it, and relate that nuance of having a black and white stripes with an animal that looks like the horse has higher probability of being zebra, and it predicts that it is a zebra, whereas it has never seen zebra any time during its training cycle or anything, right? And this is what a zero shot technique is all about, and this is what the generalization is all about in machine learning. It's relatively new way of building models, but this solves some of these problems, especially the problem of um, long cycles and what is preventing us from making simple to build machine learning systems on complex human conversations like this. Now, typically when you're going to go through your adoption cycle, it's also going to need to iterate, because your users, your customers, if you have for your app, they are going to change the way they talk, their own requirements are going to change and things like that. So you need a system that is really able to generalize, so that it's not stuck with whatever data you had at some given point and is no longer able to generate relevant predictions, because now suddenly your customer is talking about a new product in their sales call and the training doesn't work anymore, right? So the system, if it is able to generalize, it can solve this adoption cycle problem, and you can iterate fast. Generalization also allows you to make your models general enough to avoid training altogether, even if you want to calibrate it. So even if you want your model to calibrate based on the newly found information, it can adapt to it without actually looking at the new model or new data, as long as it falls into its existing knowledge, right? And so that's what the adoption cycle gets really, really robust and easy and fast, and almost as good as a typical development lifecycle. Now, this is just an overview of what Symbol's API does, and this is exactly what we do at Symbol, by the way. So I'm going to use this diagram just to explain how the flow of information moves, and I would like to show some examples of this working in live action through some of the pre-recorded videos. So if you see here, you need data from all sorts of data sources, even textual conversations, not just audio and video. Once you ingest those through one of the Symbols ingestion APIs, you could use either the real-time mode or the async mode of processing. And depending on which one did you use, you either get in real-time pushback events or push events to you as they are happening in the conversation, or you can just demand them through something called a conversation API, various aspects of it. Now, um, this is one example that I want to show very quickly. So this, I'm just going to explain what it is doing behind the scenes before I show it. So this example uses Symbols, some of the APIs in real time. So it uses streaming API, so it streams direct audio from Android app. So it uses microphone of your Android device, directly pushes that into Symbol streaming API, and then generates the generates the different types of insights such as action item, follow-ups, question topics, etc. in real time, and does that. This application, we have built it using something called as Agora extension. So it's built with something called Agora. If you're not aware of it, it's a audio video uh, infrastructure platform that lets you build your video audio calling applications. So let me just jump into the example real fast. I'm going to mute this one. So here you can see that this is a call between two parties, Mike and Jane. They are talking about a customer support request that Jane has for Mike. Mike is acting as a customer support agent here, and you can see it's trying to do real-time transcription, also separated by speaker and everything perfectly. And I'm gonna skip this ahead a little bit to talk about more interesting stuff. And as this is happening in real time, as it is trying to obviously capture the transcription and everything of this call, but if you move to this section of insights, you'll see that it's in real time trying to detect all these different things. It's trying to detect that what was the initial request by Jane or Mike, sorry, Mike for Jane, what they agreed on the next action, what is the follow-up that Jane needs to do, and so on, right? So these all things just happen by simply ingesting data into Symbol, and no training, nothing was required. So it was really just plug and play system. Same with topics. These were the main things they talked about. Jane had not white noise issue. She had complaint on her mobile phone, and so on. And there is something called trackers that I'm going to show a specific example of. But tracker actually uses the generalization approach so that you can build anything you want, any kind of classifier. It could be a classifier to detect typical intents, entities, or even something more abstract or even more complex. And I'm going to show what that is and how it adapts without any training data. So it can really just start working in few milliseconds without actually going through any kind of training cycles, and actually can start detecting them in real time. And so they had in this example a tracker configured to, so they wanted to know whenever there is an indication of bad service by customer, it should be tracked. So this is what this tracker ended up tracking. Now, moving on to the next example quickly, and I want to emphasize on that again that the previous example was really just pushing data into streaming API and just subscribing to the events and just rendering them in the app. There was model building activity or even data calibration or activity was done at all. Now, this is much more straightforward and simplistic example, and also shows how the code snippets look like in actually building this. So I'm going to walk through that little bit to understand how that tracker mechanism that uses this zero shot generalization approach actually enables us to build something like this so cool. So
Hey
trackers,
Tashish, this is
sure,
Chelsea, the
sure,
stage manager. Just wanted to let you know that you're at the end of your time. So if you would be so kind as to do this demo very quickly and to wrap things up out of the
absolutely,
kindness for the other presenters today, I would really appreciate it. Thank you.
absolutely. Thanks, Chelsea, for
You're welcome.
cool.
Take
So
the
I'm
yeah,
gonna,
take
yeah, sorry about that. So I'm gonna do this really, really quick, like in 1 minute or so. Uh, and so I'm going to skip ahead of these things. Essentially what's happening here is this is where the tracker is being created in the code, and it has three different examples to detect if somebody is going through financial hardships. And quickly here, as soon as a tracker is detected, this code here essentially is going to modify the request to now start detecting if they need loan or not, right? So instead of going through the entire video, I'm just going to show you where the results occur. So here, it detected that a customer had a financial hardships. So the actual thing that we created tracker with was very different from what customer actually said, right? So they said that I'm having hard time paying my bill, but was the configured things, but they said I'm not able to pay my bills. And then it actually in real time, while conversation was going on, modified the request, and it started detecting if they would like to apply for loan. And they said that uh, something we created tracker with was to somebody is thinking about applying loan, and when they actually said that, they said kind of similar thing, but all of this just happened in real time while conversation was going on. So that's just to show how that works. And thank you so much for it. If there are any questions, I can do that, or I'm available on the chat. If you guys need me, you can connect with me on my Twitter handle @ToshishJ. And thank you so much.